Welcome, this is Algebra 2, Semester 1, Unit 5, Section 5.4. First thing we're going to look at today is special factoring. We've been using these in class. I just wanted to give you examples of these. We have the difference of two squares. A good example would be x squared minus 1. If you have that and you're trying to get something completely factored, you need to make sure and recognize that as a difference of two squares, because 1 is squared. And that would become x minus 1, x plus 1. That is the most common of differences of two squares that I've seen where students will not see that. So make sure when you see an x squared minus 1, it is a difference of two squares. Now, in this sum of cubes, give you an example of what we might have, is we might have x cubed plus 8. First step is I would rewrite that as x cubed plus 2 cubed. And then I would look right at my formula and realize that for every a I've got an x, for every b I've got a 2. And then I simply follow that. I know that x plus 2 is a factor. And then if we remember right, the perfect square of a binomial is similar to this. We have x squared, and then minus each of these multiplied together, so that would be 2x. And then the last one squared, 2 squared would be 4. The only place you have a negative in that is in the trinomial. And the next one, the only difference is that the negative is in the leading binomial. So if we have, let's try a different cube, x cubed minus 27. First I'd rewrite it, x cubed minus 3 cubed. Now I do the same general format, but up here, x minus 3, not plus. Okay, and now back here in the trinomial, I will have all positives. So I have x squared plus 3 times x is 3x plus 9. Okay, so that's our pattern. I gave you a bunch of practice problems. I won't do all of them online with you. You'll do some in small group tomorrow in class. So make sure to be there because you'll be working with others. If you remind me, we'll use it as a warm-up time for you. If the whole class isn't there, then I'll just give you small group time to work on that. So here we want to factor. And the first thing that we see is that we can factor out an x. So we pull an x out. Remember, factoring is the opposite of distributing. We can't pull a number out because the leading coefficient is 1. So that leaves us with x times x squared would give us that x cubed plus 2x minus 15. Now, if you remember right, when I showed you in class, we can do a shortcut here. Think of two factors that multiply to be negative 15, add to be 2. Well, if it multiplies to be a negative 15, we know that we have a negative in one, a positive in the other. And the two factors of 15 that have a difference of 2 would be 5 and 3. The larger one will have the same sign as the middle term, so x plus 5, x minus 3. Don't forget to bring this x down from the front. That is your final answer. Okay. Next one, we could factor out a 3y cubed, because 3 will go into both of those, and y cubed is our smallest exponent on our variable. So that would make y squared minus 6. Next one, we can factor out 4 from each of those, and z squared is our smallest, so 4z squared. That would give us a z squared plus 4z minus 4. Okay. That might look like a perfect trinomial square, but it is not, since the final term is a negative. So we can't go any further, just because we have to have factors that are opposite signs. Oh, wait a minute, can we? Negative 4 and... No, because a negative 4 and a positive 4 and a negative 1 would be a positive 3. So we can't go any further on that. Okay, next one. Hopefully you see that as a perfect sum of perfect cubes. So we rewrite it, x cubed plus 4 cubed. And now we go to our formula. Remember with the sum, it was the root plus the root, and then our only subtraction sign's in the middle term here, so it's x squared, 4 times x, and then the last term squared, 16. Okay. Next one. On this one, let's see, we could pull 2 for sure out of those, and a p squared. 2p squared would leave us with an 8p cubed plus 125. Now you may not notice, but you should have your perfect cubes memorized so that you would see that 8 is perfect cube of 2. So that becomes 2p cubed plus 5 cubed. Okay? We'll just hold on this one coming into the answer. I don't want to get it confused with what we're going to do now. So this is the sum of 2 cubes, just like what we just did up here. So we take our first binomial, it's the cube root of each with a plus between it. Then we take the square of that, that would be 4p squared. Our only minus is right here in that second term. 5 times 2p is 10p. And then we take the square of our last term, 25. Now bring your term that we first took out up on the GCF factor and write it in the front, and that is our final factored version. Okay? Next one. There's nothing that can come out of all of them, so let's try doing a 2 by 2. We could pull x squared there. That would leave us with x minus 3. We need to repeat that over here, x minus 3, and we would have to multiply by a negative 16. Negative 16 times negative 3 is positive 48, so we're in luck. We can factor out x plus 3, x minus 3. And now the other term that we have is x squared minus 16, which I hope you see that's a difference of 2 squares. So we factor that down now to being x minus 4 and x plus 4. Don't forget to bring your x minus 3 down into that answer as well. Okay. Up above, this is a difference of 2 squares. 16 is a perfect square. 81 is a perfect square. And x to the fourth can be broken into x squared times x squared. So we have 4x squared minus 9 times 4x squared plus 9. Love those difference of perfect squares. They're so fast. You just take the root of each and put a plus and a minus. Now, if you notice, this is a difference of 2 squares again. So we can go 2x minus 3 and 2x plus 3. Now bring down your 4x squared plus 9. Always be watching for those difference of perfect squares. I personally really like to have them in your problems to keep you alert of those. Next problem. We could factor out the p squared for sure. It looks like we can also factor out a 2. So we take 2p squared. That leaves p to the 6th plus 5p cubed plus 6. Now we look at that, and we can do the shortcut on this. Let's just circle this one to take into our answer. To do the shortcut on this, two factors that multiply to be positive 6 would be 2 and 3, and they add to be 5. So I would go ahead and put p cubed in the front, because p cubed times p cubed will equal to p6, plus 2 and plus 3. And now bring into our answer 2p squared. Okay. Be sure to pause the video and come back to these and look how to do them. On these next 4, I ask you to try. I am simply going to write the answer. I want you to pause the video and see if you can figure out how to get it. If not, please ask questions in class, ask questions of each other. See if you guys can figure it out. If you can't, then see me and I'll explain it. The answer for this one should be x, this is number 9, x times x minus 5 times x minus 2. The answer for number 10 should end up being 3y cubed, y minus 5, y plus 5. The answer for the next one is a difference of 2 cubes. Should end up being x minus 3, x squared plus 3x plus 9. Now you make sure that you're filling in the other steps. After the video, solve those. If you can't get them, then see me. This one, the final answer is x minus 3, x plus 3, and x plus 7. Okay. Final page of notes. This is a difference of 2 squares. 625 is 25, 16 is 4, and g can be split into g to the 4th. So we have a minus and a plus. 25, 25, 4, 4. Now this one happens to be a difference of 2 squares again. So we go 2g squared minus 5, 2g squared plus 5, and we bring down the 4g to the 4th plus 25. Okay, our next one, I would factor out that 4t squared first on this one, because 4 and t squared will go into everything. So we get t to the 4th minus 5t squared plus 6. Now from that, negative 2 and negative 3 would be good factors there. So we get t squared minus 2, t squared, minus 3, and then bring down your 4t squared. Okay. See me if you're having trouble on these shortcut ones. The only reason we can shortcut is because we have a 1 as that leading coefficient in the polynomial that we're factoring. Okay, this last section we're finding the zeros of a number solution. Now by finding zeros, what we're basically doing is looking at the eventual graph, just like we did in that first lesson. And we're finding zeros. Let me find the graphs right here. That in your equation would have been a 0. This is a 0. It's where they cross or touch the 0. And we'll explain as we go. in future lessons when you know that they're tangent and they just touch, or when they actually cross. So for right now, let's just solve these equations to find the zeros. These are the real number solutions. Okay, so the first thing that we do is we get the terms all on the right side of the equation. So 3x to the fifth, and then to get rid of the 18x cubed on the right side, we subtract it from each side. We get negative 18x cubed plus 15x equals 0. Now we factor. 3x would factor out of all of those. So we get x to the fourth minus 6x squared plus 5 equals 0. Now I look at this and I say, well, do I have two factors that will multiply to be positive 5, add to be negative 6? If I do have them, they would both have a negative sign because they have to multiply to be positive, add to be negative. As I think through my factors of 5, I think of 5 and 1. They multiply to be 5, they add to be negative 6. Remember, you can only do this shortcut if the leading coefficient there is 1. Otherwise, you have to play the x game. Okay, so now the square root of x to the fourth would be x squared, and now we bring down our 3x. We have a product property of 0, which states that if you have two numbers multiplied together and they equal 0, one of them has to equal 0. So now we set each of these equal to 0. We should go ahead and factor this difference of two squares, x minus 1, x plus 1, although you could get the 0 without doing that. I just like to see them fully factored. So you set each of the factors equal to 0, so when 3x equals 0, divide by 3 on each side, that's when x equals 0. So when x equals 0 and we plug it into this equation, the whole equation ends up being 0. X minus 1 equals 0 when x equals 1. We add 1 to each side, so there's another 0. X plus 1 equals 0 when x equals negative 1. Again, we just use our basic math to solve these little problems. X squared minus 5 equals 0. Well, we add 5 to each side, so we have x squared equals 5. Now to get rid of the square root, or the square, we square root it. So we get x equals plus or minus square root 5. Okay, so we have 4 different zeros, actually 5 different zeros for that polynomial. And that means on the graph, they're either touching or crossing the x-axis at 0, at 1, at negative 1, and at plus or minus radical 5. Okay, so the next polynomial, we go ahead and we get that term that's on the right-hand side over to the left-hand side by subtracting, getting rid of it on the right-hand side. So we have 2x to the fifth minus 14x cubed plus 24x equals 0. Now we would look at that. What can we factor out? We could factor out a 2x. So we have x to the fourth minus 7x squared plus 6 equals 0. We can take a shortcut. What two factors multiply to be positive 6, add to be negative 7? That would be x squared minus 6 and x squared minus 1. We bring down our 2x. Now we set each of our factors. Again, we have x squared minus 1. So I'm sorry. I made a mistake there. That should have been a 12. Okay, so let's try this again. So we would have x squared minus 4 and x squared minus 3. Okay, again that was 12 because I factored out a 2, and 2 times 12 is 24. So now the x squared minus 4 is a difference of 2 squares, so x minus 2, x plus 2, x squared minus 3, and 2x. Set each of those equal to 0. We have 2x equals 0. Divide by 2 on each side, we'd have x equals 0. X minus 2 equals 0 when x equals 2. X plus 2 equals 0 when x equals negative 2. And on this one, not so easy to do in your head, x squared minus 3 equals 0. We add 3 to each side, so we have x squared equals 3. Take the root of that, x equals plus or minus square root 3. Okay? Next problem, I'd like you to do these last two on your own and see if you can get the correct answer. Work together to make sure that you get that. If not, call me over. The zeros for the second one here, x equals 0, x equals 1, x equals negative 1, x equals 3, and x equals negative 3. So you have 5 different values for your zeros in that problem. In the last problem, we need to use, let me just show you that one because it's slightly tricky. You have to go back to using your, oh gosh, I'm a blank. So embarrassing on a tape to have my mind go blank. I don't really write notes for these tapes. I want to say Pythagorean theorem, and it's not. It's Quadratic Formula. So in case you've forgotten it or you haven't been in Algebra 1 lately, let me just go through it real quick. We get this negative 6x to the fourth, the other side of the equation, so we have 6x to the fourth minus 27x cubed plus 15x squared equals 0. Again, we do that by getting rid of it on the right hand side by adding 6x plus 4, and we do that to each side, so it ends up being a 6x plus 4 on the left hand side and nothing on the right hand side. Now we can factor out a 3x squared out of all that. We'll draw a line and bring it into our answer. Okay. What we have left in parentheses is 2x squared minus 9x plus 5 equals 0. Now we need to multiply to get a positive 10. We could do 10 and 1, but they had to be 11. Negative 10 and 1 would have to be a negative 11. So we can see we can't factor it, but we need to solve the equation. So we go back to the quadratic formula, which says that x equals plus or minus, oops, I'm sorry, not plus or minus there, a negative boy couldn't decide whether or not to go to a radical party, b squared, without 4 awesome chicks, because it all got over at 2 a.m. Now, you might say, what did you just do? That is the formula, that's how I remember it. And we match this up because ax squared plus bx plus c is where we get the letters from. So if we write our equation right below that, 2 will be our a, negative 9 will be our b, and 5 will be our c. So we take our formula, negative 9 plus or minus negative 9 squared is 81 minus 4 times 2 is our a value times 5 is our c value, all over 2a, 2 times 2, that's our a value. So we go ahead and we solve this. Negative 9 is 9, plus or minus radical 81. 4 times 2 is 8, 8 times 5 is 40, so it's a minus 40 all over 4. So that's 9 plus or minus radical 41 divided by 4. That is 2 possible zeros, two real number zeros. Our other real number 0 would be to take this 3x that we had up here, 3x squared, set it equal to 0, and solve. X squared equals 0 because we've divided by 3 on each side. So x equals 0. So we have that 0 and then these two. I can put x back in there. The reason these are two different ones is on one you would add the radical 41, the other one you'd subtract the radical 41. Okay. That is the end of Unit 5 notes. Get the study guide from me and get prepared for the test on this. Thank you very much.